Hello, let's talk about hotel reservation system, a relatively common system design interview question. We're gonna go over clarifying questions and requirements, high-level components, data schemas, talk about distributed lock-in, how to organize payments, and whether we wanna handle overbooking, and if yes, and how to do it. So we need to start to understand what the scale is, like how many hotels, one, many, or like are we even building for specific hotel or network or aggregator reservation system like something like Expedia or Booking.com. Then we need to understand like how many rooms are in the hotel, like some small hotel or like large multi-story hotel. Do we support online booking or on site as well? Can like people pay with cash, for example? And how do they verify themselves? And is it like in scope or out of scope? Do we support cancellations? We probably should. Do we have overbooking? And how do we resolve situations when there are not enough rooms? In case yes. For hotels, overbooking is not that great because there are not as many good mitigation factors. But there are some possibilities, so I'm gonna cover that in case like we really wanna do it. And then another question would be what payment methods are supported? Is it just a card, or like people can pay with cash on site, or maybe some like Apple Pay, or some like on other systems. So that can give a good start. We're probably gonna be building a system for like a specific hotel network, but we're gonna assume that there can be like many hotels. Aggregator reservation system can be similar, but the scale and like queries can be quite much bigger. And also another case we may consider is if we are integrating into aggregator system with our like hotel system. But for now we're gonna keep it simpler and just like assume that people are booking through the hotel network website. High level components would be like relatively simple here. So we have like a web app. So we have user, some load balancer, some API gateway for like authentication, rate limiting, caching, and routing to backend services. Then we have one or several databases. I think if we have just one DB, multiple tables makes it easier, but in some cases it's not like feasible. So I'm gonna discover like how do we deal with a harder case when we have like multiple DBs. So we're gonna have hotel DB for storing like various hotel information, and a reservation service for storing and handling reservations. It's gonna talk to hotel service and also payment service, and I'm gonna use external payment system. I'm gonna go over this in a couple of slides. But building a payment system yourself is very difficult, and you need to be subject to various regulations. And also, if you want to support multiple payment methods, it makes it even harder. Data schemas. So we have hotel. Hotel, we have probably just ID, name, and address. Then we have room type. We're not actually gonna have specific rooms, and I'll explain a bit later why. Brief answer is like it's harder to manage bookings, and like especially if you want to do some kind of overbooking, then it's crucial to not like tie to specific rooms. And room type is gonna have type, hotel ID, foreign key. It's gonna have name, some occupancy, description, and count. We can also potentially have total count and reserved count. Or we can try to do it using the reservation table, which I'm gonna go over like in a second. So we have like user, have some user ID, first name, last name, email, phone, maybe like some payment information. But again, if we store payment information and save it, we are subject to more regulations. So ideally, like at least if we are just building a more like simpler system, we delegate this payment system to some external one. And then we're gonna have a reservation. So it's for a specific room type. That's how they are typically offered. It's for a specific hotel by a specific user, and start and end date. We can also include other information like what's the fee for the room, but it can be dynamically changing. And then like we need some calculation when we have start date and end date, how we like query total price, plus there may be additional fees calculation. So yeah, and yeah, we're gonna be using SQL database for this because we really need ACID properties. We don't want to deal with like inconsistency situation. We want atomic operation. Like if you book it, it should either like tell you that, hey, sorry, like somebody else booked it, or it should just go through. Let's talk about distributed lock-in and what may be needed to ensure that like we don't double book the same thing. We don't exceed the threshold of how many we can book. There are like two typical ways to do it. There may be more, but I'm gonna go over like the main ones. Strict lock-in, so it's like, well, like what you think about acquiring a lock, but we lock each database, maybe each table with maybe using TTL, do some operations and unlock, and maybe using some like coordination system to handle that. But then the trick is, if they work, yeah, they work precisely, but it's susceptible to deadlocks if there are partial failures. Also, if it's implemented poorly, we can like lock one database and like in different order, for example, and then like two queries are just waiting. The user experience can be bad, so it just like kind of hangs and just users sitting waiting. There is soft lock-in, which works quite a bit better for this kind of a problem. So we include a counter with data and increment it by one when doing operations. So like when user is about to do operation, they do like a read. The read returns this counter, and new value is incremented by one, and then when we write, we have like a validator that new value should be old value plus one. If it's not, then declares there's been a conflict. So just to give an example, suppose this like value is like 0 and two users are trying to book at the same time. So they would both read 0 and they would try to write 1, but after like because we have ACID properties, after like one of user like that has a successful write, the value would become 1, and like for another user it's going to be 1 and 1, so like validation would fail. And then it's a bit of data overhead, but it's not susceptible to the logs, and we can improve user experience. We can say that maybe like in case if there's a contention, we can say, hey, this room is like popular now, or we can just even like pre-say it even before the booking, or show like how many people are viewing this room, so that user, when they like get some errors, they feel like, it must be like because like people are trying to book it, so okay, let me just try again. It's quite a bit better. Then let's talk about payments. I briefly talked about this. So yeah, we're gonna use external payment system, and they already support various payment methods. Payment service submit request to the system, and there can be also webhook for a payment system to call back when the payment is processed, in case it takes some time. We need to carefully design the system to like either like be fast and like have payments processed quickly, or we need to like allow users to delay the payment and like maybe have them page which shows that, hey, the reservation is in progress and they're waiting for payment to be like fully authorized. Then when webhook is called, we like can send a new page which shows that, hey, everything is processed. And let's talk about overbooking. It's not as a good idea for hotels as for airlines, for example, because for airlines usually there are like better alternatives. You can, like in the worst case, get on another flight in a couple of hours, or you can get a voucher for some money, maybe like travel in a maybe different day in worst case. With hotels, it's not as flexible because if you like show up there and there is no room, then like what if there are no rooms in other hotels? But in case we really want to do it, like maybe it's a worse trade-off sometimes. I actually don't know how many hotels actually do it. Like I know that for example on Expedia it shows like, hey, we have this many rooms left at this like of this type. So it kind of highlights that maybe they don't do overbooking in many cases. But yeah, suppose we want to do it, and or suppose we like our problem would be not a hotel reservation system but airline reservation system, which in many things would be similar, but maybe we would need to handle overbooking there. So yeah, we are gonna maintain counts per room type instead of booking specific rooms, and that's important. That's like what I've been mentioning before. It would make it easier because then we just need to like maintain, hey, how many rooms are like of given type are booked, how many are like total, and then we just have some threshold, and we like if you don't want to overbooking, we just like set the threshold to like total number of rooms. Otherwise, we set it to something like total number of rooms plus maybe 5%. And like doing it per room type can be a bit better because we can like offer another room type when like say we overbooked and more people showed up. Especially if we like offer a better room, then like people are likely not complain. But even if it's like a bit worse room, we can offer with some like voucher, maybe the refund partially or something. So there are ways to make it kind of work. But from infrastructure perspective, we we just like maintain counters, and we do some like lock-in mechanism to make sure we don't reach threshold, like whatever the threshold is gonna be. Cool. Thanks for watching.